Hello and welcome. In this video, we're going to be attempting to solve a question from the 9709 Mechanics paper 4 exam. This was June 24, and this question is a tough one because you will see in part C, we are doing two ideas in one. We will be using conservation of momentum and kinematics simultaneously to solve this question. So it's interesting, it's new. So let's start by reading the question and trying to solve part A. So the question says, a particle of mass 0.2 kilograms is projected vertically upwards from a horizontal ground with a speed of 25 meters per second. So let's say this is my horizontal ground, which I will take as my reference point. So any displacement, I'm gonna measure it from this reference point, and I'm going to take the upward direction as positive. So anything acting upwards is positive, and any displacement that is above this horizontal ground is also positive, and anything in the other direction, which is downward, is going to be negative. So it says that I have a particle over here. It's projected upwards with a speed u equals 25. Why positive 25? Because u is pointing upwards and up is my positive direction. So it's positive 25 meters per second. Okay, part A shows that it says show that the speed of p when it reaches 20 meters above the ground is 15. So 20 meters above the ground, so my S is above my reference point, and above or up is positive, so my S is going to be positive 20 meters, okay? And I want V. So what is V over here? What is V? So let's see what do we have for this particle. We have U, which is 25 meters per second. We have S, which is 20 meters. We have acceleration. I know that acceleration is basically going to be the acceleration due to gravity. However, acceleration is pointing downwards, so I'm going to take a negative acceleration, so it's going to be negative 9.8 meters per second squared, and I want my V. So over here, I wrote the Saviot equations, okay, SAVUT, and in front of each letter, the equation that doesn't include that letter. So I will come here and I will look. These four quantities are of importance to me. Which one didn't I mention? I didn't mention T. I don't want it and I don't have it. It's not very important for me. So right away, I will just use the equation in front of T. This is how I solve. It makes my life easier to choose which equation. So let's say V squared equals U squared, which is 25 squared, plus 2 times acceleration, which is negative 9.8 times S, which is 20. So V is going to equal the square root of all of this. So let's try and compute that. 25 squared plus 2 times negative 9.8 times 20 is going to give me an answer of 233. Square rooting that is going to give me an answer of around 15.26. Actually, here, if we used G as 10, here it wants us to use G as 10. Yes, so let's use G as negative 10 meters per second squared. This is going to give me a better answer. So here we use G as 10, not 9.8. So it's going to give me an answer of 225. And when I square root that, it will exactly give me 15 meters per second. So now this 15 meters per second is a positive direction. So I know that the velocity here is 15 meters per second upwards. Okay? So this is part A. Let's try and do part B. It says when P reaches 20 meters above the ground, it collides with a second particle of mass 0.1 kilogram, which is moving downwards at 20 meters per second. So let's see what's happening here. So this is my horizontal ground, okay? Now P is here, which I calculated that it was moving with a speed of 15 meters per second upward, and it was 20 meters above the ground. It says that when it reaches 20 meters above the ground, it collides with another particle. Let's call it particle Q. So this is Q, this is P, and this is the point where they collide, which is 20 meters above the ground. Let's say this point over here is 20 meters above the ground where they collide. Q is moving 20 meters per second downward. And it says that P, after the collision, P is brought to instantaneous rest in the collision. So we know when we deal with collisions, we're basically using the conservation of momentum. So B says find the velocity of Q immediately after the collision. So let's write the equation for conservation of momentum. It goes like this. So M P U P, so mass of P times the initial velocity of P plus mass of Q times the initial velocity of Q should equal the mass of P times the final velocity of P plus the mass of Q minus times the final velocity of Q. So let's see what we have. So the mass of P was 0.2 kilogram, the mass of Q is 0.1. So 0.2 multiplying UP. So P before the collision, immediately before the collision, was moving with a speed of 15 meters per second upward. Let's take up as positive. So it's going to be 15 plus MQ, which is 0.1 times UQ. U is 20, however, it's pointing downwards, so I should put a negative sign in front of that. Now I'll have MP times VP. Okay, what's VP after the collision? It told me P is brought to rest, so V equals 0 right after the collision, so this term is basically 0. Plus MQ, which is 0.1 times VQ, which is what I want. The question asks the velocity of Q after the collision. So here I can compute this as 0.2 times 15 plus 0.1 times negative 20. This left-hand side is going to equal 1, and this is going to equal 0.1 VQ. So VQ is basically 1 divided 0.1, which is 10 meters per second. And from here, I know that the velocity of P is having a positive direction. That means that after the collision, Q is going to move 10 meters per second upwards. Okay, so this until now is I believe all is okay. Here where it gets super interesting. So it says when P reaches the ground, it rebounds back directly upwards with half of the speed that it had immediately before hitting the ground, and it says find the height above the ground at which P and Q next collide. Okay, this is a lot. So up till now, we know that P hit Q. After the collision, P was brought to instantaneous rest. This is at 20 meters and is gonna accelerate downwards. This is P. And for Q, after the collision, we are moving with 10 meters per second upwards, and also we're accelerating with G downwards. So it says that after this collision, obviously P is going to start to fall and is going to hit the ground, okay, and rebound back up. Okay, the speed while it was hitting the ground, let's say it's V, and it tells me in the question that the speed of the rebound is going to move immediately after rebounding. It's going to move up with the speed half of that was here on the ground. So the best thing to do in this equation is to divide every single scenario and calculate everything at that scenario so we know what's happening. So let's start by calculating what happens to P and Q in the scenario where P now is 0, having a velocity of 0, and it's falling down. Let's calculate the speed of P while it falls down and calculate how long will it take to fall down to the ground. Let's start by doing that. So for P, we are going to have U as 0, and I'll take downwards as positive to make my life easier. So U equals 0. I know that my acceleration is now equals to 10 because it's pointing downwards. I need my V, and I have my S because this is 20, so it's gonna fall this distance to the ground, which is 20 meters, and it's also downward, so it's also positive. So now I want V. Again, I will use V squared equals U squared, which is 0, plus 2 times acceleration times S. So V is going to equal the square root of 20 times 20, I believe it's 400. So square root of that is going to give us an answer of 20 meters per second. So now P is here having just immediately before the rebound or hitting the ground, it has a V of 20 meters per second downwards. Let's see how long did this take to happen. So now I will need my time. And a tip I calculated, now I have everything. I have my v, which is 20 meters per second. So I can use any of the equations to find time. However, a tip, it's always best to use the equations with all the givens, because if you did something wrong in the calculation here, let's say you calculated at 17, you're gonna carry this error into the time over here. So when you can, this is not always applicable, but when you can, always use the most amount of givens, or all of the givens, to minimize potential errors. So let's take the equation that doesn't have a v. So I will come here and look which equation it is. It's this one. So it's s equals ut plus half at squared. So s, which is 20, equals 0 plus half times acceleration, which is 10 times t squared. And from here I can calculate my t. It's going to be 40 divided 10, so 4 equals t squared, and t equals square root of 4, so t equals 2 seconds. So it took 2 seconds for p to reach the ground. Okay, so now let's see what happened to q in those 2 seconds. Okay, so now 2 seconds have passed. V is here with a velocity of 20 meters per second, and it's about to hit the ground. Let's see what happens for q in those 2 seconds. So for q, I know, let's take up as positive now for q. I know that my u was 10 meters per second upward, so it's positive 10. I know that my time that I'm interested in was 2 seconds. I know that my acceleration is going to be negative 10 meters per second squared, because acceleration is downwards. And I want how far did this q go. So let's say s. How much is s here? Okay, we need to see where is q after these 2 seconds. So now s, I can use the equation without a v again, which is s equals ut, so 10 times 2 plus half times a times t squared, so t squared, so this is going to be 20, 4 divided 2, so this is 4 divided 2 is 2, times negative 10, so that's negative 20, so my s is going to be 0. Okay, that's super interesting. So what's happening now, if this is my ground, I know that now p is here after 2 seconds, p is here moving with a downward velocity of 2 meters per second. This is the point of the collision, which was 20 meters. And now q, in those 2 seconds that p fell from here to here, what happened to q is that it went up and it went down again. And after the 2 seconds, it has a displacement of 0. It means that from here, because this is now my reference point for q, so my s 0 means that q now is here. So this is q. This is p. Because when I calculated the things for q, I started from here. So when I have an s of 0, it means that q is now here as well. Okay? So now q is here. This is after 2 seconds. Right, let's see what's gonna happen now. So now q is moving downwards. Okay, so I need to see what speed is moving. Is q moving downwards with? P is super easy. I know that p is gonna rebound back up with half of the velocity that it was moving with. Why? Because here it told me that p rebounds back directly upwards with half the speed that it had. So if it had the speed of 20, so it's gonna rebound upwards with 20 divided 2, which is 10 meters per second. So now p is moving like this. But before that, I will need, from here, I will need to calculate what is the v, okay, at this instant. What is the v at this instant? So again, I'm going to use the equation without an s, okay, which is v equals u plus at. So v equals u, which was 10, plus a, which is negative 10, times time, which was 2 seconds. So now my v is equal to 10 minus 10 times 2, which is minus 10 meters per second. And here I took upwards as my positive direction. So when I get a negative direction, I know that this velocity is negative and it's a negative 10 meters per second. So at this instant, after 2 seconds, this is exactly what's happening. P is moving upwards with a 10 meters per second. Q is moving downwards with 10 meters per second as well. And let's say that they will collide after Q going down and P going up. This is P dash, Q dash. So let's say they're gonna collide at this distance over here, which is, let's call it distance x. Okay, so if this is x, this whole thing is 20 meters. So this is basically 20 minus x. So now let's try and solve for this distance over here. So let's say for P, what's happening for P? Let's take upward as positive for P. I have U equals 10 meters per second upwards. I have acceleration equals negative 10 meters per second squared. I have my displacement, which is basically x. I want to see when does it reach x, and I want to find obviously what's going to be important for me as well is the time, because the time for this P to reach here is going to be the same as the time for Q to reach here, because they're colliding. Colliding means they are at the same position at the same time. So let's use the equation of the thing that's least important for me, which is V. So I will use S, which is x, equals ut plus half times negative 10 times t squared. So this is my equation for P, and I'll call it equation 1. Okay, let's erase this. Okay. Now, let's do the same for Q, taking downwards as positive. So I have U, which was 10 meters per second downward. Okay, now I will have U as positive 10 meters per second. But you're going to tell me it was negative. Yes, it was negative in this calculations when we were taking up as positive. Now we're starting again from scratch. So I will take my downwards direction as positive, and I know that U is downwards, so it's going to be positive. So the best thing to do in order to not confuse what's up and what's down, and what's negative and what's positive, is to think about, is it moving downwards or upwards, and then choose a direction that's positive and be consistent with that. Okay, so U is 10 meters per second, A is 10 meters per second squared, S is basically 20 minus X, because this is my S, and again T equals the same time that they will so basically T equals T, which is the time that they will collide on again. So I will use S equals ut plus half at squared. So S, which is 20 minus X, equals ut 10t plus half times A times T squared. So let me put these under each other to see what's happening. So I have an X equals 10t. Okay, half times negative 10 is basically minus 5t squared. And this over here, I can rewrite it as half times 10, which is basically 5. So this is 5t squared. And let's erase this part to make it. So this is 5t squared. Now I will need to solve these two equations simultaneously in order to find my x. So I can see right away, if I added these two equations together, it's super, it's gonna make my life super easy. Basically, this is simultaneous equations. You can either substitute this x over here and solve, or you can use elimination. You feel free to use whatever you want. I will add these two together. So 20 minus x plus x is 20 minus x plus x. These two are gonna cancel. So basically, I'll have 20. This 20 equals 10t plus 10t is 20t, and then I have a positive 5t squared plus negative 5t squared, which is 0. So this is super easy. T is going to be 20 over 20, or T is going to equal 1 second. And in order to find the distance from the ground, which is basically x, I will substitute this T 1 second onto this equation. So x is going to equal 10. Instead of T, I'm going to put 1 minus 5 times 1 squared. So this is going to equal 10 minus 5 times 1 squared is 5. So this is going to give me an answer of 5. So my x is going to be 5 meters from the ground. This is the point where they will collide again. Hope this was helpful. Super important. Please consider subscribing because I will be posting lots and lots of helpful content. Don't forget to share, like, and comment down below if you have anything you want to say. Watch the previous videos, and thank you for watching.